For our last example here, we have a word problem. It says Sophia hits a softball in the air. The path of the ball looks like a parabola. So it looks like it's making kind of a swooshy parabola shape, or an umbrella, not an umbrella, a rainbow shape. The equation models the height, h, of a ball after t seconds. How long is the ball in the air? So the ball goes up as time passes, and then it's going to come back down. So we want to know how long that ball was up in the air before it came back down to the ground. Now this equation may confuse some because it talks about h and t instead of y and x, but those are going to be interchangeable. Y is going to be the same thing as h, so if you need to look at that as y, and t is going to be the same thing as x. So negative 16x squared plus 47x plus 3, if that is helpful. If it doesn't bother you to have the h and t there, don't worry about it. Now we are going to use our calculator to help us solve this, but I want to model what this will look like. So we have the first quadrant where x and y is both positive. Time and distance is not going to be negative, so we're not worried about what happens to our parabola past the x-axis or past the y-axis. We're not going to have negative time. And so when we go to graph this, when we graph it on our calculator, we will see that the ball immediately starts at a height of 3 because of that y-intercept. So the ball starting at 3 feet, maybe that's the height of the person throwing the ball. And then that ball is going to go up in the air, up, 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 up for an undetermined amount of time, and then it's going to come back down. And so what we want to figure out is what time is that ball coming back down. So when is it hitting the ground? So we are going to use our calculator to calculate that. So in our calculator, we are going to go to y equals, and we're going to type our equation as we see it. I'm going to clear out anything that was already there. And don't forget that h is going to be the same thing as y, and t is going to be the same thing as x. So I'm going to type it in to my calculator just as I see it on my paper, but if I see the letter t, I'm going to use an x. So it says negative 16x squared plus 47x plus 3. Now I'm going to hit graph and see what it looks like. Whoa! So this is a very kind of skinny parabola. It looks like it is going to open down, especially since a is negative. It's that negative 16. And what we are really looking for is any positive solutions. Again, this question is about time. It's talking about after t seconds, how high, the height of the ball after t seconds. So we want to know how long the ball is in the air. So if you imagine, time is not going to be negative and neither is height. So we're really going to focus on just the first quadrant. So everything where the x and y values are positive. So if we look at the origin from 0, 0, that's where we're starting at time and height. The ball goes up as time progresses and goes really, 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 really high. And then as time progresses, it comes down. So we want to figure out when the ball comes back to the ground, at what time is this occurring? And that's going to be our x value. So we're going to look for the x value or the solution where the ball falls down. So we can kind of guesstimate from the tick marks on our graph here. It looks like it's happening at about 3. I'm going to look at our table, so I'm going to hit second and table. And again, the solution is going to occur when y is equal to 0. So if I look at my y values, I see a 0, and that happens at 3. So that's going to be at 3 seconds. 3, 0. 3 seconds is when the ball comes back to the ground. So the ball is in the air for a total of 3 seconds. So as we saw on the calculator, our ball hits the ground after 3 seconds. So it spends 3 seconds in the air. If you remember, your origin is 0, so 3 seconds goes by, and that ball comes back to the ground.